Calculators today. All right, we're going to hit 2 little units here. We are on page 57. Page 57. All right, everybody ready to roll? Let's go, Colton.
Yeah, I'm ready.
Working on it.
You're an athlete, Colton. Let's go.
This is going to be an obscure joke for some people, but I'm doing it anyways. Yeah, I'm ready to roll initiative.
I don't get it.
It's a D&D thing. Dungeons and Dragons?
I didn't get that one either, Dre. I'm sorry.
Does nobody in here know Dungeons and Dragons?
No.
I don't watch that show.
How does it work?
Nope. Jumping into this. All right. Page 57. The definition of the derivative tells us the rate of change of the function at a point. Correct. It would be a constant rate of change. Yes, that's a great question. Okay, or statement. The derivative of a function tells us the rate of change of the function at a point. So sometimes you're just asked to pick out the meaning in a multiple choice question. Explain the meaning of f prime of 3 equals -7. So we would say the function f of x is changing at a rate of -7. Now that's not everywhere, that's specifically at x equals 3. Okay, the function f is changing at a rate of -7 at x equals 3. And I'm going to highlight this word rate. If you don't have the word rate, you've got nothing. The moment we talk about a derivative, you have to be talking about its rate. Okay? The function f of x is changing at a rate of -7 at x equals -3.
Should you write average rate of change, or do you not have to because
It's one moment in time, right? So it's not an average. Approximating the derivative. The derivative of a function at a point tells us the slope of the line tangent to the curve at this point. Okay, so just to be clear, every time you hear derivative, you should be thinking it's talking about the slope. The slope is the rate. Okay? Sometimes we are not able to find the exact derivative. In these cases, we will approximate or estimate the derivative using the average rate of change, which we talked about yesterday. Not sure. That's my fault.
irritating me.
I'm sorry, Dre. So is his headache. His headache's irritating me.
I don't really care that much.
About my headache, Dre?
No, about the thing on the paper. Don't misinterpret my words on purpose.
I didn't. All right, approximating and estimating derivatives. So if you're given a table of values, you are always going to use 2 points and find the average rate of change. Okay, so again, table of values, we're using the average rate of change to estimate the derivative. If it's a graph, okay, we're going to find the slope of the tangent line. Okay, and now if it's an equation of f of x and you're allowed to use the calculator, okay, so we will let you know when you can and cannot use the calculator, you are going to use the feature n derive on your calculator. Okay, so if you can use the calculator, you can use this feature, which we'll talk about in just a few minutes, this n-derive feature.
Wait a second. For the table of values, wouldn't that just be finding the average rate of change between the 2 points, like the secant line, not the
Right, as we said,
derivative or tangent line?
average rate of change between 2 points for table of values.
But then it wouldn't be the derivative, though. wouldn't
It's
it?
an approximating or estimating the derivative, yes. All right, so example 1. This function is continuous. I want you to highlight that word. We got to make sure we're continuous and differentiable with selected x values given above. We want to approximate f prime of 2. So again, this prime is approximating the slope. We are looking for the slope at 2. Or again, it's an approximation. This is not exact. We don't have an exact function. We have just some random table. So all you're going to do is you're going to say, where does 2 fall? 2 falls between 1 and 3. So I'm going to use these 2 points to approximate my slope at 2. So I'm going to say, using function notation, of course, f of 3 minus f of 1 all over 3 minus 1. Okay, so I'm going from 1 to 3, bless you, because 2 falls in between there. So now we'll just crank out the math. F of 3 is 1 minus f of 1 is negative 2. And 3 minus 1 is 2. That's going to make a positive. I should get an approximation of 3 halves. Okay, so let's try another one in the table. If I wanted to find the approximated slope at 5, between which 2 points would I pick? 3 and 7 this time, because it falls in between there. So I would do f of 7 minus f of 3 all over 7 minus 3. And again, this is an approximation of what we think the slope is. F of 7 is 5 minus 1 all over 4. I'm getting approximately 1 is my slope. And again, just an approximation. Now I'm going to add one more. What if I wanted the slope at 3? What 2 numbers do you think even though 3 is on my table, what 2 numbers would give me the best approximation? 1 and 7. I'm going to pick the 2 that surround it. So if I wanted the slope at 3, again, the approximated slope, I would find f of 7 minus f of 1 all over 7 minus 1. Okay, I don't think we need to crunch the math, but I just want to be clear. You're going to pick the 2 that surround that value. Okay.
Figuring out a better way to figure out my question from earlier, but it's an issue. Get out of here.
All right, you hold that thought for a minute. We'll get back to your question. Okay, so let's say you're given a graph. All right, we said if we're given a graph, we're going to use the idea of a tangent line to help us find the slope. And again, this is not exact science right now. It's just an approximation. We'll get the exact math later on, where you're just approximating. So I'm going to go to -2, and I'm going to try to draw the best darn tangent line I can. Tangent means it's only touching the curve once. So if it goes through, it's probably not your best tangent line. That may not be my best tangent line, but it's close. Okay? So I'm approximating what I think the slope is, and I'm just trying to find like a point that I think it's going to hit at. So I'm thinking it hits here, and then, geez Louise, I'm going kind of steep. 1, 2, 3, 4, 5, 6, I don't know, maybe 7-ish till it hits this line up here. Okay, I've got a positive value, so I'm going to say it's approximately 7.
Do you need to put the approximately sign if it's asking you to approximate?
Probably not, but I'm just stressing that this is an approximation. It's not dead science here. Okay. G of -1. So I'm going to go to my -1. Again, I'm going to try to draw the best tangent line I can. Okay, so I'm thinking, let's see, that kind of looks like, I'm saying it's kind of close to 1. Goes down a little more, over a little more. I'm going to say it's approximately 1. And again, we want to be in the ballpark, okay? All right, you got the idea that we're ballparking these with the tangent line? I'm going to skip those 2. Example 3. for which values is g prime equal to 0? So again, when you read g prime, you're thinking the what?
Actually, can we go back to C?
Hold on one second, I'm in the middle of this. G prime, we're thinking what? Slope. I am thinking, when do I have a slope of 0? So think about what a slope of 0 looks like. What type of line gives you a slope of 0? Horizontal. I'm picturing a horizontal tangent line. How many times could you draw a horizontal tangent line on this graph? Twice. Approximately, we'll stick one in here. I don't know, that looks like 2 and a little more. I'm going to call it approximately 2.2. And I'd say another one, I could draw a horizontal tangent line up here. I don't know, approximately negative 0.8. Again, I'm just approximating where I think that horizontal tangent line is, where I could have a flat line. Drew, you wanted to hit C here?
Yeah, just because
Okay.
I put the dot there and I can't see any sort of tangent line that wouldn't go through the tangent.
Yes, so this one, because of the bend of the curve, it's going to end up going through it at some point.
So does that mean that there is none?
Nope, there definitely is. We just got to put your best approximation on there. It kind of goes through at that point, right? I think it hits about here. I'm going to say it's about negative 4. Down 4 over 1.
Because I was like, you said that it can't work if it goes through.
Right, well, I'm
like that one.
trying to stress you're not drawing like a secant line. You're trying to draw your best tangent line. Okay. Example 4 says put the values in order from least to greatest. Now again, because these are primes, we're talking about their slopes. So you're looking at their slopes. What do you know about the slope at 0? What type of number is the slope at 0? If you were to put a tangent line there, definitely a negative. So I'm going to put an N for negative here, maybe NEG, negative. How about at negative 2? What type of slope do we have? Definitely positive. I'd say that's pretty steep too.
It's the one we did earlier with the 7.
There we go. And how about G prime of positive 2? Not quite 0, because I think the 0 is over at like 2.2-ish. So it's slightly what? Slightly negative. Okay? So I want from least to greatest. So at G of 0, would you say 0 is steeper or this negative 2 is steeper? 0. So I would say that's my most negative, G prime of 0. Then my G prime of positive 2. Sorry. And then my G prime of negative 2. Okay, and I didn't need an exact number. I'm just kind of looking at the steepness of it. Try B. Try to list those in order from least to greatest. All right, so in this case, at 0 and at 1 and at 2, all the slopes are what? They're all negative, right? So now we need the most negative, would be the smallest. We need who is the steepest. Am I the steepest at 0? Am I the steepest at 1? Or am I the steepest at 2?
My issue that I ran into was that at 0 and at 1, they're both like almost exactly the same. 'Cause it's like on a straight line.
I'd say 1 is definitely steeper than the other, slightly. Who do we think is the steepest? I'd say 1 looks steeper than 0. Then 0, then 2.
I'm not font, so I can see it because I can.
Well, I've drawn all over my paper, Dree, so I'm not sure. So, like, I'm going to put my tangent line here. So do you see that line? Now compare that to this slope. That definitely got, this was steeper than that, right? And then that's less steep. All right. Next little part says approximating a derivative with a calculator. So pull out your handy dandy calculator. All right, so a couple things about the calculator. Is anybody taking physics? One? Just one person? Okay. So for everybody else, you are always going to have your calculator in radian mode. Okay, for the one person taking physics, physics is all in degree mode, so you're going to have to switch carefully between classes. Or every question in physics is going to be wrong, or every question in calc is going to be wrong. Okay, so right now you can just hit your mode, put it in radian mode, and you should never have to touch it as long as you're not Stephanie.
How do you
Hit mode. Radian's like the fourth thing down, hit enter on it. Okay, so you have to be in radian mode. So, to take the derivative, it is in the math section. So box that in. And you are looking for n derive. Okay, when you don't know where something is, most likely it's under the math feature, but we're going to go math n derive. So when you pull it up, we're going to hit math. N derive is number 8, so you'll get used to hitting math 8 a million times. Math 8 is n derive. This is our notation for the derivative. So this is who you're taking the derivative with respect to. So what's the letter in our problem? It's always going to be x on this calculator. This is the function you're taking the derivative of. So our function is the ln of x cubed plus 11. So we need ln, we need x cubed plus 11, close the ln parenthesis. And now this x equals is the moment in time we want the derivative. So we want the slope at option A is, or h prime of -1. So I'm going to put in -1. So this will find us the exact slope at that moment in time. And we'll just go, I forgot, this whole course also is 3 decimal places. Okay, so it will not tell you to round ever. It's always 3 decimal places. Unless you're in physics. It's something different. You'll have to keep them straight because I can't remember what it is in physics. But it's 3 in calc. Okay, so 0.300 would be the slope at -1 exactly. Okay, so if I want the slope at 0, just get used to, we're just practicing the buttons for the time being. We're getting math 8, n derive, always with respect to x. I'm going to go on the ln of x cubed plus 1, closing that ln button. And part B says I want the derivative at 0.
Yeah, it's 11, not 1.
That would help because that's a really big number. Are we getting that? Okay. What's that? What does that E mean here? Scientific notation, move the decimal 8 places to the left. Okay, so point 1, 2, 3, 4, 5, 6, 7, 9,095, which is obviously each to 3 decimal places going to round to 0. So again, math 8 pulls up the derivative. I know I'm redundantly typing this in. We're just practicing these buttons. X cubed plus 11. Close that. And I want it at 4. And again, I'm just going 3 decimal places. 0.639, which is going to round to 0.640. Okay. Do the same thing with example 6. We'll skip D there. Bless you. It wants the derivative, so it wants the slope at -2. So pull up your n derive feature, type that in, specifically at -2. Or whatever it said there, -2. Math 8, taking the derivative, pulling up that fraction tool. We've got 3x plus 8 over 1.2x plus e to the x at x equals -2. Does that -0.837 sound good for the first one? -0.837. I'll do one more here. Getting -0.127 for B. Got the idea with the n-derive feature? Okay. Flip the page. All right, we're going to squeeze both of these in here. All right, we're going to really work on these tangent lines and notation here. All right, so there's several ways to indicate a derivative of a function. So notation-wise, f prime of x is telling you to take the derivative. Okay. You might see it rewritten as dy dx, which is saying take the derivative, or just y prime. Okay. So any of those three are telling you to take the derivative, and again, the derivative is just a fancy word for slope. You are looking at the slope. Okay, so again, a reminder, the derivative tells us the slope of the tangent line to a function at a given point. We also want to write equations of tangent lines. It is key to remember that a tangent line is just a line. Okay? And to write the equation of a line, you need two things. You need a point and a slope. It is literally called point-slope formula, which is why you need a point and a slope. And again, that's y minus y1 equals m times x minus x1. Okay, m is our point, or I'm sorry, m is our slope or our derivative, and the x1, y1 is our point. All right, so different ways you're going to see this expressed. So example 1 says, a function f of x is continuous and differentiable for all values of x. It is known that f of 4 is 7. So they're giving you the what here? The point. The point is 4 comma 7. And f prime of 4 is 2. So now they're telling you the what? Telling you the slope. The slope at 4 is 2. Write the equation of the tangent line at x equals 4. So simple. Y minus, what's my y1? 7 equals my slope, which is 2, times x minus 4. We are not cleaning these up. Don't solve for y. Leave it in point slope form. Unless it's multiple choice and you don't see it looking that way.
I don't know if it would, but would it ever ask for, like, it gives you the point and or slope at 4, but then asks you to find the equation of the line tangent to f of x at a number that isn't 4?
It usually does, and it's usually about the point they give you.
Okay.
Yeah, I mean, could they? Yes, but it's usually about the point they give you.
What would you do if they did?
Fine, they'd have to give you something else, either the equation or something else. Example 2, the function g of x is defined here. So they're going to twist it a little bit. It is known that the derivative is this. So again, the what is this? The slope. Write the equation of the tangent line at x equals -1. Okay, so now they're giving you less information. You've got to be a little more of a detective here. You know x is -1. Can you go get y yourself? Absolutely. Who are we plugging this into? G of x. So if I get g of -1, that will give me the y value. Okay, do not use your calculator. None of this will be calculator active. So -1 squared is 1. -3 times -1 is +4 plus 5. Did I do that right? That was, wait, say that again. That should be a, oh, jeez Louise. I was going to say, something didn't feel right. Does 9 sound good? Okay. Now I need, so I have the x, I now have the y. I have to get the slope. Now they didn't just say the slope is 5, they're telling you the equation for the slope. So now I have to find g prime of -1. So 2 times -1 minus 3. I should get -5. So now I have the x, I have the y, I have the slope. I've got to put it all together to write the equation of the line. So y minus y1 equals my slope times x minus x1. That minus negative is going to turn to a plus. Okay? Again, equation of the tangent line. All right. Try to give different information of questions you're going to see here. The function h is differentiable for all continuous values. Write the equation of the tangent line. Okay, so this time based off a table. So they give us x and h of x. What is h of x, another way to say? Y. And what is h prime saying? Slope. Okay, and they want it at x equals 1. So if x equals 1, based off this table, what is the y value? -5. And what is the slope? -4. H prime is giving me the slope. So all right here. There's my x, there's my y, there's my slope. And then just put it all together. Y minus -5 equals -4 times x minus 1. So y plus 5 equals -4 times x minus 1. Do the same thing for question 4. Write the equation of the tangent line at x equals -2. What's our y value at -2? And our slope? 0. So y minus 3 equals 0 times x, really, who cares? What's going to happen here? Those cancel, and I just get y equals 3. I get a nice horizontal line of y equals 3. All right, number 5's the beast here. Let k of x equals this function. Write the equation of the tangent line at x equals 3. Okay, so the only thing they gave me was x, so the first thing I can go get is the y. So let's find k of 3. That will get me the y value. So that's 9 plus 15 minus 3. What do we get for a y value? What's that? Everyone go with 21? Okay, now here's the ugly part. They did not give us anything about the slope, the derivative. So we got it, as of today, we still got to use the long way to figure this out. So we have the limit as h approaches 0. Remember, it's f of x plus h minus f of x all over h. So we're going to do the limit way one more time, apparently, until we learn the shortcuts tomorrow. Monday. All right, so I'm going to take the limit as h approaches 0. I need to evaluate f of x plus h. So I'm plugging x plus h in how many times here? Twice. So I have x plus h squared plus 5 times x plus h minus 3 minus just the f of x function. All over h. All right, so take your time cleaning up that algebra. Got my 3's to cancel, my 5x's to cancel, my x squareds to cancel. So I have 2xh plus h squared plus 5h over h. I'm going to take an h out of everyone. So I get 2x plus h plus 5. And then when I take that limit, I get 2x plus 5. Okay, so now I just have, so this is my derivative, and I just have to plug in the number 3. So I'm just going to be clear. This is f prime, and now I want f prime of 3. So 2 times 3 is 6 plus 5. I should get a slope of 11. So putting it all together, I've got, I'm just going to put it here, y minus, what did we say that y value was? 21 equals the slope of 11 times x minus 3. All right, last one. Says calculator active again. So using a function p is defined here, write the equation of the tangent line at x equals e squared. Okay, so I know x is e squared. What do I have to go get? I need the y value, so all I'm going to do is plug in e squared, and I'm just going to use my calculator. So I've got the ln of e squared, whoops, what did I hit? E squared plus 7. Make sure you've typed it in correctly. I've got the e squared squared in there. Are we getting a 4.120 number? No? You got e squared in there? E squared squared? No? Did anyone else get this number? Leo, try this.
I messed it up.
Oh, you did? Okay. Gotcha. So remember 3 decimal places. So I'm going to say that y value is 4.121. Always 3 decimal places in this course. Okay. Now I need the slope, which tells me to take this guy's what?
You did get 4.12, right?
4.121. 3 decimal places.
Because you got round.
Okay, so now I need the slope, so I have to use the derivative feature. So I'm going math 8 for my n derive with respect to x of the ln of x squared plus 7. And I want the derivative when x equals e squared. So I'm taking the derivative of that function when x is e squared. I'm getting 0.240 when it rounds. Any questions on those 3 numbers? And then just putting it all together. So y minus 4.121 equals 0.240 times x minus e squared. All right, let's see, where does that leave us? As far as the homework goes, I think it's the 2 pages that follow. So 61, 62 front back, and then 63, 64. Okay, so we've got about 7 minutes here. So you're doing both 61 through 64. Which I think are pretty nice, especially that first page. So I'll give you a few minutes to get started.